Yeah, this is on page 112. So if you look at the example the textbook has done on the right, again, what they did is they moved everything over to one side and made it equal to 0, because then you would graph it and find x-intercepts. Something we've been doing more of is we've been taking one side of the equation and putting it into y1, and taking the other side of the equation and putting it into y2, and then you just have to find out where the two graphs intersect. So both methods work fine. We're going to type this into our two equations here. So our one equation is x, and the other equation was 8 over x squared plus 1. Yes? Yeah. Just type it in here.
I know I could use the other graph, but how do I change it back to equals instead?
Oh, you just go up to it and then hit that button.
Oh.
Should
I pressed like every button and it wasn't working out.
alpha,
Oh, okay.
and then hit it.
Thanks.
Yeah. All right, so here we go. Now we can hit graph. So there's the graph of 8 over x squared plus 1, and here comes the graph of y equals x. And we can see that they intersect only once. So when we want to find our intersection point, we're going to push our second button and then trace. Above it, it says calculate. Number 5 says intersect. Push enter. It's going to ask you first curve. It's automatically on the blue one there. I push enter. It hops to the red curve. Push enter again. And then it asks you to guess. And there's our intersection point. There we go. Now, when we type it into y1 and y2, it'll give you two answers, and a value for x and a value for y. The question only has x's in it to begin with. The reason it got y values is because we added the y when we had one equation in y1 and one equation in y2. So for a solution to this one to the nearest tenth will just be x is approximately 1.8. Questions you can do for this one are number 8.